Let's begin with the introduction of alkanes. Now, before I forget, you will be able to find the notes in the description below. So, for each topic, I'll be uploading the notes in the description, and in the end, you'll have the compiled one in the introductory video as well as the last video of this chapter. I have not uploaded the one for the introductory yet. So, alkanes. Alkanes are basically an example of a saturated hydrocarbon. So saturated means they do not have double or triple bonds. So they don't have these, right? So alkanes are also called as paraffins. Now, the reason they're called paraffins is because they do not show a lot of reactivity at normal temperatures and pressures. So, they don't react with reagents like acids, base, oxidizing or reducing agents under normal temperatures and pressures. However, they require a special set of conditions, and that makes sure that they undergo a chemical reaction. So, paraffins means param means little and affins means affinity. So they have a very little affinity towards undergoing a chemical reaction, and so they're called as paraffins. Now, methane is the first member and it of alkanes, and its molecular formula is CH4. So it is a gas which is found in coal mines and at marshy places. So this is the structure of methane. Okay, here you have, it's a tetrahedral structure. If you remember, we had discussed all of this in the previous chapter. We talked about the structure of alkanes, alkenes and alkynes. So here, methane, we're just talking about methane and it's tetrahedral. Now this carbon atom is going to be sp3 hybridized. So there is an overlap between the sp3 orbital of the carbon and the 1s orbital of the hydrogen. So there is a sp3 and 1s orbital. There's a bond between these two. And you have a bond length CH bond length is going to be 112 picometers. And the HCH bond angle is 109. Since it's a tetrahedral, 109.5 degrees is the angle between the HCH bond. Now, when you have methane, okay, so methane is CH4, right? Now, when we replace one of these hydrogens, oh, I'm sorry, you can't see it. So, methane is CH4. Right. Now, when one of these hydrogen atoms is getting replaced by a carbon, okay, now when we add a carbon atom, okay, first let me just replace one of the hydrogen atoms. So methane, and I've replaced a hydrogen with a carbon. Now carbon's valency is 4. So the remaining 3 bonds are going to be with hydrogen atoms. Then we get an ethane. So this consecutive addition of a carbon atom to the chain, there is a specific name that we'd learned in the previous chapter, and it is called homologous series. So methane, ethane, propane, butane, pentane, hexane, all of these form a part of the homologous series, and so they will have a general formula. So the general formula for alkanes is CnH2n plus 2. So let's start with the first one. So when n is 1, it is CH, 2 ones are 2, plus 2 is 4. CH4, which is methane. Okay, and next let's replace n with 2. So C2H, 2 2s are 4, plus 2 is 6. This is ethane. Here again C3H, 2 and 2 3s are 6, plus 2 is going to be 8. This is propane. And then C4H, 4 2s are 8, 10. So this is butane. And the next one is going to be C5H, 5 2s are 10, plus 2, that's 12, that's pentane. So in each case, we have increased the chain by one carbon atom. So we started with CH4. Okay, then we went on with CH3, CH3. There is an addition of another carbon atom, introduction. Then you have a CH3, CH2, CH3. And then you have CH3, CH2, CH2, CH3. Right, and CH3, CH2, 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 and the CH3, which is out of the board by right now. Okay. So here, as you notice, with each carbon atom, as we go down the homologous series, we have an addition of a carbon atom. There's an increase in the number of carbon atoms by 1. So this is called the homologous series. So the general formula for such a thing is CnH2n plus 2. And one more important thing, the bond angle when we talk, bond length of a CC bond is about 154 picometers. So for each of these, that is alkanes, alkenes and alkynes, we'll be starting with the structure, then talking about the methods of preparation. We'll be talking about the isomerism, then we'll be talking about the methods of preparation, physical properties, chemical properties, and so that's going to be common for all the 3 that we're going to be learning about in this chapter. In the next video, we will be learning about the nomenclature and isomerism of alkanes.